Hello and welcome to IB and A-Level Learning Center, and this is Mr. Tai. In this video, I would like to help you to solve a problem, number 5 in IBDP Physics High Level in the most recent test, 2026. Events A and B are shown in space-time diagram drawn for a frame of reference F. Events A and B are 4 kilometers apart as measured in F. Okay, let's observe this diagram. We have the two axes, x-axis measured in kilometer and the CT time axis. Actually, CT here, it is also measured in kilometer. Let me explain a little bit about the meaning of the CT. This is the product of the speed of light c, which is 3 times 10 to the power 8 meters per second, and the time. So we have that thing CT. Okay. The speed is measured in meter per second, and when we multiply with the time in second, we get the meter, or we can convert that into kilometer, 10 to the power 5 kilometer. Okay, kilometer here. Multiply with the time, we get the kilometer. So, for example, a value here on the CT axis, value 10, the product, this thing is 10 kilometer, which means the time t is 10 over 3 times 10 to the power 5, which is extremely small value. Okay, but because we want the two quantities on the two axes are the same in kilometer unit, so instead of using time in second, we use the CT. Okay. The event A occurs at this coordinate. The time is 0. Here, the origin, the distance, the position is 0, and the CT is 2. So we can write a coordinate like this, 0 and 2. Okay. The event B occurs at the position 4, and the CT is 3. Which means they do not occur at the same time. They occur at different time. The difference between CT delta, the difference, CT is 1 kilometer. Extremely small amount of time, but technically it is different, not simultaneous in this frame of reference F. Okay. Question A: calculate the space-time interval between events A and B. When you see this keyword, you can directly relate to the formula in the booklet, which is this formula. Let me circle it, this one, the space-time interval, which means you can take this formula and substitute the value into this formula and immediately get the result. Okay, let me rewrite that formula again. I like to emphasize the meaning of this space-time interval. We have the two events, like the two lightning striking two trees at different locations, such as one tree in Saigon and another tree in Vũng Tàu, and there's a difference in time, like 1 minute later between the two events. Okay, and we can combine the two differences, position and time, in this single quantity, which is called space-time interval. Its meaning is that it is a constant. The only thing which is constant, regardless of reference frame. For example, when different people use different coordinate system or different reference frame to measure the difference in position between the two locations, and also different in time, using different clocks and different starting time to measure the difference in time between events, they may disagree with each other about the simultaneity, about the differences in x distance and in time. However, when they calculate the space-time interval here in their corresponding reference frame, it is always constant, regardless of observer and reference frames. Okay. For now, substitute the value in this formula. Delta x, the difference in position, is 4 compared to 0. Let me write that difference, 4 minus 0, and then square. And then the difference in CT, one event occurred at 3 and the other 2. 3 minus 2, and then all square. We have here 4 square and the other 1 square. So the sum is 17. 17. That is the difference. Sorry, I remember the formula. It is the difference, not the addition. Sorry, let me adjust this thing. Yeah, the difference, which is the subtraction here, 4 square minus 1 square, which is 15. Okay, so this one is square root of 15. Use a calculator, you get approximately 3.9 kilometer. Now let's move on. Question B. An observer is moving at speed v away from F. Events A and B are simultaneous. For O, determine V. Okay. The two events in this new reference frame is simultaneous, which means the difference in time between those two events, delta t prime. This time difference must be 0. Okay. And to write the expression of this time difference, we need to use the formula, this one, for part B. Note that in this formula sheet, this is the transformation of the time from one reference frame to the other prime reference frame, like a spaceship moving with a certain speed, which is compatible with the speed of light. Okay, but with the difference in time, and therefore I will write gamma here, and instead of only time, I need to use the difference in time, delta t, difference in time of the reference frame F. Okay, and then subtract v over c squared time. Instead of x, I use delta x, different in position. Okay, and because we do not know the time specifically, we know the ct, time difference. So I mean the product on the vertical axis. So I need to multiply this expression with speed of light, which is a constant. So because it equal to 0, so when we multiply with a constant c, it is also 0. Now I will multiply c to each term here. We have gamma multiplied with c delta t minus v. C on top and simplify with c squared at the bottom. We have c here at the bottom and delta x. Because this thing equal to 0, so it means the two terms are the same, and the difference is 0, which means c delta t equal v over c times delta x. Now substitute the value into this equation. C delta t time difference is 1 kilometer. I mean the whole difference in ct is 3 minus 2. 3 minus 2, which is 1. Okay, 1 on the left hand side equal v over c of delta x, different in position, which is 4 minus 0. Okay, let me write that thing, 4 minus 0. So the ratio v over c is this one, 1 over 4, which means 0.25. So we conclude that the speed of the spacecraft, the moving observer, the reference frame O, is 25% the speed of light. Okay. One more thing from the part A, we see that this delta S space-time interval is greater than 0. It means there is a space-like separation, which means that the distance between the two events are greater the ct, which means even with the speed of light, a signal cannot travel from one event to the other event, which means that the two events are completely independent and does not relate to each other. It's not a causal relationship, which means one event does not create another event. They are totally independent. Okay, it's the meaning of this space-time interval, which is space-like separated. Question C. Calculate the distance between event A and B as measured by O, the prime reference frame. To find this distance, we use the space-time interval delta S square. Delta S square. It is constant, which is 15 that we got from part A. Okay, it is the square of the difference in distance, and ct, the difference in time, ct square. It is constant, which means it equal to the difference in position in the prime reference frame, the frame of reference O moving. Okay, square here, multiply with the difference in ct prime square. This is the reference frame O moving. We call it the prime reference frame. Okay, this one is 0 because in this O reference frame, the two events are simultaneous. The two events are simultaneous. Okay, and this one, the delta S prime, is what we need to find. Okay, here 15 on the right hand side, left hand side, of course. 15 square, sorry, 15, just 15. So because the second term is 0, we can easily conclude that the difference in position in this reference frame square is 15. Therefore, the difference in their position is, or simply say, the distance between two events is the square root of 15, which is 3.9 kilometer, and it coincidentally equals the space-time interval in part A. For this part C, actually, there's a second method which is simpler, okay, compared to the method using the space-time interval. That method is simply just the length contraction. We have the formula of length contraction. Let me look for it. Just gamma, the Lorentz factor, exposition. That formula is not given here. We have, okay, sorry, this one. This one, the length contraction is the proper length divided by gamma, but to use this second method, we need to assume that the distance 4 kilometer, the delta S in the reference frame F is the proper length, which means we assume that it is a fact, which is the answer of the next part D, and we use this formula. Let me write that. The distance between the two events in the reference frame O, which is delta S prime, is the delta S, assuming that this is proper length, which is 4 kilometer, okay, divided by the gamma. So if we check it, this is 4 kilometer, and the gamma is 1 over 1 minus V square over C square. Okay, we can check that with a calculator, huh? The proper length is 4 divided by the gamma Lorentz factor, which is 1 over the square root of 1 minus C square over V square. And because the speed of the reference frame O is 25%, 0.25% of the speed of light, the ratio is 0.25, and we square it. Okay, we get this value 3.87, which is approximately 3.9 that I wrote for the space-time interval. Which is the square root of 15. Actually, the 3.9 is a rounded value. And the more accurate value when we take the square root of 15 is exactly the same with for the formula here, which means 4 here is supposed to be the proper length. And the answer of the final question here explains why 4 kilometers is the proper length. Proper length means that it is measured by a reference frame by an observer which is stationary compared to those two events. The two events occur in the same reference frame in which the observer is stationary. Okay, so we will say that because it is measured, the distance 4 kilometers is measured by observer who at rest in the same reference frame with the two events. So that's why the 4 kilometers is the proper length. Thank you very much for spending time and watch this video. If you have any comment or suggestion for my explanation, please leave a comment. Thank you.